Let's get into some better problems here. It says determine all vertical asymptotes of the graph h of x equals x squared plus 2x minus 8 all over x squared minus 4. Let me show you a mistake that a lot of students make. A lot of students say, oh, well, vertical asymptotes are where the denominator equals 0. So they'd have this as x squared equals 4, and then they'd take the square root, and they'd get x equals plus or minus the square root of 4, which is x equals plus or minus 2. Hopefully they're good enough to write that as 2 separate values here of x equals 2 and negative 2. But this is completely wrong. This is not how you do the problem. Remember, that would be what are the intervals of continuity? What is the domain of the graph? That is not what the question is. So what we have to do first is try to factor and simplify. If we factored the top, we need two numbers that we have x squared plus 2x minus 8, and on bottom we have x squared minus 4. So on top we want to try to factor it. We need two numbers that multiply to be negative 8 and add to be 2. I'm getting x plus 4 and x minus 2. Please check my factoring real quick. And on the bottom, two numbers, it's a difference of squares. X squared minus 4 factors into x plus 2 and x minus 2. Notice now that we can simplify the factors of x minus 2, and we're left with the rational function x plus 4 over x plus 2. Now, and only now, do we set the derivative equal to 0. So I'm going to set x plus 2 equal to 0, subtract 2 from both sides, and that would give me x equals negative 2. That is my only vertical asymptote in this problem. I highly recommend that you graph this function on Desmos to see what the heck's going on. Well, let me show you what's going on in general when this happens. If you don't factor, so for instance at x equals negative 2, here's x equals negative 2, you're going to see something like this, okay? I don't know which direction it goes. It goes to plus or minus infinity. What I'm getting at is it is very clearly a vertical asymptote. So the question is, what happens when x equals 2? Well, when x equals 2, you're going to see something like this. You're going to see an open circle. So anytime you're able to factor and simplify, you're dealing with a case where there's an open circle. Again, I am not saying that this is the graph of this function right here. I'm encouraging you to graph this function on Desmos and seeing what's going on. I'm just talking about general behavior. If you factored and simplify, any place where it actually simplified is a hole in a graph. Any place that it didn't simplify is a vertical asymptote. So if you just set the denominator equal to 0, you are going to get the wrong number. Okay, let's look at these next ones right here. It says find each limits, determining the limits. It says the limit as x approaches 1 from the left of x squared minus 3x all over x minus 1. Notice if we plugged a 1 in here, if we plugged a 1 into this function, which is what you traditionally like doing, right? You would have 1 squared minus 3 times 1, and then you would have over 1 minus 1. Well, that would be a 0 in the denominator, a 0 in the denominator. That's not going to help us out at all. The 0 in the denominator means it's undefined at that point. So what do we have to do for this? Well, look, one thing we could do is look at the graph. Again, we could go to desmos.com, we could graph this and see what's going on, but there's going to be a little bit of an issue with that because we don't have graphing utilities during the test. So what I would rather you do for showing work for this one is I would rather you do the table and chart. So here we're going to have x, and then we're going to plug it into our function. Remember, our function here is x squared minus 3x all over x minus 1. We have the number 1 that we're looking at, right? But 1, we know that it's undefined at 1. So we need to plug in, and I want to see 3 numbers. And notice this is from the left. So these are going to be numbers that are smaller than 1. So I'll go with 0.9, 0.99, and 0.999. Just 3 numbers to the left. Again, this is something that I'm going to put into the table feature of my calculator. So I'm on my TI-30XS multi-view calculator. I hit table. I clear out whatever function's in there. I hit the fraction button. I'm typing in x squared minus 3x in the numerator. I hit down to go to the denominator. I type in x minus 1. I hit enter. It doesn't matter where my start is. It doesn't matter what my step is. Make sure you have ask x highlighted. Hit enter on OK, and then we're just going to type in these values. 0.9, enter, 0.99, enter, and then 0.999, enter. Okay, again, we got to be careful here because I am getting fraction values. So for instance, the first one I'm getting is 189 over 10. I go up and I highlight that using my arrow keys. I go up and I highlight that, and then I hit the double arrow button right above enter to see what the value is, and I'm getting a y value of 18.9. I hit down, again, I'm going to hit that double arrow button. I'm getting 198.99, and then I go down to 0.999, and I'm getting 1998.99. What I want you to notice, though, is what happens as I go to the right. So 18.9 to, I'm going to say roughly 900, or sorry, roughly 19, to roughly 200, to roughly 2,000. That number is getting bigger and bigger and bigger, so it's growing without bound, or increasing without bound, if you want to say. And that tells you that the limit as x approaches 1 from the left of x squared minus 3x all over x minus 1 equals infinity. Grows without bound. That number gets closer and closer to infinity. So let's not try to do too much work on these problems. Let's just use our tables. Our tables are our friends. We can see what happens, okay? Part B, the exact same function. The only difference here is now we are coming from the right-hand side. So it's still x squared minus 3x all over x minus 1, and we're looking at the limit as x approaches 1 from the right. So let's do the exact same thing here. We have x, we have f of x. Again, here the value 1 is undefined. I want you to try at least 3 numbers to the right of that. I'm going to try 1.1. Let me use different color here. 1.1, 1.01, and 1.001. Okay? So, nice thing here, it's already entered into my calculator in the table feature, so all I have to do is change the x values that I plugged in. So I'm going into where I plugged in 0.9, my first x value, and I'm going to trade that out for 1.1, enter, 1.01, enter, and 1.001, enter. So I'm just changing out those x values. Again, here I want to go up and highlight the y value, hit the double arrow button to get the decimal version of it. And I'm getting it for 1.1, I got a decimal version of negative 20.9. Going down one for 1.01, I got negative 200.99. Going down one even more, I got negative 2000.999. It doesn't really matter. Notice what happens as I go to the left. So I go from roughly 20 to roughly 200 to roughly 2000, all negative. So that is decreasing without bound. And because it's decreasing without bound, I could officially say the limit as x approaches 1 from the right of x squared minus 3x all over x minus 1 is equal to negative infinity. Again, this does not mean the limit exists. Technically, the limit does not exist, but it approaches negative infinity. And again, if this were on the test, I do not want you to write d and e. I want you to write negative infinity. Okay? So I know that the limit doesn't exist, but you still can tell me the behavior, and that's the point of the problem, is to tell me the behavior of the function or the graph. Okay, so let's look at properties of infinite limits here. It says let c and l be real numbers and f of x and g of x be functions that the limit as x approaches c of f of x equals infinity, and the limit as x approaches c of g of x equals l. So what happens if we add, subtract, multiply, divide these limits? Okay, because those are all rules. Remember, the limit of the sum is the sum of the limits. So what happens if you have something like, this first one says, what happens if you have something like, I don't know, infinity plus or minus 5, some number? Well, that still equals infinity when it comes to limits. The next one says, what happens if you have something like infinity times 5? Well, that's still infinity times 5 is still infinity, and infinity times negative 5 would be negative infinity. So that's what that's saying right there. And then what's the next one say? The next one says, what's something like 5 over infinity? Well, infinity is a huge, huge, huge number, so you have a really big number on bottom, a very small number on top, relatively speaking. So this would always approach the number 0. So anytime you have infinity plus or minus a constant for a limits, that's equal to infinity. Anytime you have infinity times a constant, that's equal to positive infinity or negative infinity. Again, for limits, we're talking about just limits here. And that's dependent on the signs of the infinity and the constant. And then anytime you have a constant divided by infinity, that limit approaches 0. And this next one's going to be, or this last one's going to be really, really important for us to use. We're going to use something like this to answer several questions moving forward.